Hello all. In this lesson, we are going to learn about stress tensor. Before going to that, let's take a look on what is meant by stress tensor. The physical quantity can be represented by three main forms. Number one is scalar quantity, in which we only consider magnitude like mass, density, volume. Number two is vector quantity, in which we need a direction to express it. And number three is tensor. Tensor need magnitude, direction, and a plane to express. The concept of tensor is widely used in solid mechanics in order to analyze how stress acting within the body. Now consider a rigid body with different external forces are acting. In order to analyze the internal stress, we could consider an infinitesimally small cubical section within the body. There are two main kinds of stresses for analyzing stress tensor. First one is normal stress represented by sigma, acting perpendicular to the plane. And the second one is shear stress, represented by tau, which is acting on the plane. Both the stress are mutually perpendicular to each other. One main advantage of stress tensor is that, no matter on what direction the force acts on body, we could resolve every force into mutually perpendicular normal stress and shear stress. Now let's look how to plot stress tensor. While marking plane, remember one thing: the plane cutting x-axis is x-plane, and the same applies to y-plane and z-plane. On expressing stress and strain, you should use two subscripts. First letter represents the plane on which the stress acts, and second letter represents the direction stress. If you see sigma xx, it means the stress acts on x plane and in x direction. If you see tau xy, it means the force acts on x plane with y direction. There is one more sign convention. If the stress is tensile or pulling outwards, it is positive, and compressive stress is represented in negative sign. In every plane of cube, there is one normal stress and two shear stress. Now, how to represent stress tensor. Stress tensor is represented by a 3x3 matrix of total 9 elements, in which diagonal elements represents tensile stress and non-diagonal element represents shear stress. For plotting the tensor, we could mark x, y, and z components in row and column-wise. Take first subscript from row and second subscript from column. You could plot the position of stress in matrix. When we consider equilibrium condition for the material, the matrix will form a symmetric matrix. That means the shear force of opposite pair becomes equal and cancel out each other. There are a lot of application of stress tensor. When you could analyze the internal stress of materials, it provides application for structural design, fluid mechanics, and more.